Hi there, this is Ms. Page, and in this lesson we are going to look at solving equations that result from right triangles involving a sine, cosine, or tangent ratio, and our skills of solving polynomial equations, especially quadratic skills. All right, so one of the things that we've learned that we will need to be using in this lesson is our square root property. So here we see an example of the structure where we have a quadratic term and constant terms. And so we can isolate our quadratic term, take the square root, we have to remember that plus minus, and then we can solve for x. So the other thing that we have previously learned that we'll need to, this has been a while, that we'll need to use is our sine, cosine, and tangent ratios in a right triangle. And so if we have an angle here, our angle is called theta. If theta is here, remember that first off, I would recommend we have to identify the three sides of our right triangle. Identify the hypotenuse first, which is always across from the right angle. What you need to remember is that your opposite and your adjacent do depend upon the location of the acute angle. Here the theta, here's theta here, where it's located. So here, when theta is in this corner here, going across our triangle makes this our side opposite our angle. And this would be our side adjacent to our angle, which actually notice is one of the sides of the angle. That's always what we mean by adjacent. It's one of the sides of the angle that is not the hypotenuse. Here, going across the triangle, that would make this side the side opposite. So notice here, this side is the side opposite, but in this previous one, it was the side adjacent. And now, this is our side adjacent, because it is part of our angle and it's the side of the angle that's not the hypotenuse. So you can also, well, the other thing is then once we have our three sides labeled, we need to know based on our information that we know which two sides do we have, and is that a sine or a cosine or a tangent ratio. So our sine of an angle is side opposite over hypotenuse. Cosine is side adjacent over hypotenuse, and our tangent ratio is side opposite over side adjacent. You can use the acronym SOHCAHTOA to help you with the definitions of sine, cosine, and tangent if you don't remember this. So S stands for sine, OH stands for opposite over hypotenuse, C stands for cosine, AH stands for adjacent over hypotenuse, T stands for tangent, OA stands for opposite over adjacent. All right, so let's take a look at a problem. We are going to find all real values of x, meaning that they can be rational or irrational, but not imaginary, that satisfy this given situation of x being part of a measurement of one side of a right triangle. And notice it says we'll round to 2 decimal places if it's necessary to do any rounding at all. All right, so like I said, first thing we need to do is start by labeling the three sides of our right triangle. Start by labeling your hypotenuse, which is across from your right angle. So that would make our x squared minus 3 our hypotenuse. Then I would recommend labeling opposite. So here's our acute angle, 35 degrees. So going across our triangle, we hit the side that measures 5, which makes it an opposite. That would make this third side here our adjacent side. But in this problem, the sides that we care about are the sides that we have information about, which are the hypotenuse and the phi, and the side opposite, which is the phi. So we need to now know those two sides, would they represent a sine, cosine, or tangent ratio? So again, you can use SOHCAHTOA to help when necessary. So we're looking for opposite over hypotenuse, and that would tell us it's a sine ratio. So we have the sine of our 35-degree angle would be equal to side opposite, which is 5, over the hypotenuse, which is x squared minus 3. So this is opposite over hypotenuse. And this creates a little quadratic equation. So we have an equal sign, we have an x squared. That's what we mean by a quadratic equation. So now we're going to solve this equation for x. All right, so here our algebra is a little different than what we've done previously. So you cannot solve for a variable as long as it remains in a denominator. So part of our algebra has to be something that will move that denominator, the variable in the denominator, to a numerator position. So usually what we have to do is undo this division. So we're going to undo this division by multiplying both sides by x squared minus 3. So now what we have is x squared minus 3 times the sine of 35 degrees. Now the sine and 35 degrees, they always go together. You cannot separate the sine and the 35 degrees. And then this reduces to 1. 1 times 5 is 5. So now what we're going to do is undo the multiplication between our x squared minus 3 and our sine of 35 degrees. So I'm going to divide both sides by the sine of 35 degrees. So now these have reduced to 1. So now I have x squared minus 3 equals 5 divided by the sine of 35 degrees. Okay, so now from here, again, remember we're solving for x, so we're doing our reverse order of operations. So that is why I undid the multiplication outside the parentheses first. Now I'm going to undo things inside my parentheses, or that were inside the parentheses. So I undo the subtraction next that was inside my parentheses, and the plus 3 should go at the end. So we're taking this fraction plus a 3. So now we have x squared equals 5 divided by the sine of 35 degrees plus a 3. And now we are going to use our square root property, take our square root of both sides, and that's going to create plus or minus the square root of everything we have over here. And so now we've got x equals, and we can use our calculator on this. So where you need parentheses. So remember that when you're doing a square root with a scientific calculator, that you have parentheses around your radicand, what you're taking the square root of. In this case, you also need to realize that you're going to have to put parentheses around your angle. Also, make sure that your calculator is in degree mode so that it understands that this angle is a degree measurement. If it's in some other mode, such as something that starts with an R, which stands for radians, or G that stands for gradians, you're going to have to figure out how to change to degree mode on your calculator. All right, let's use our calculators and see if we agree. All right, so hopefully you came up with positive or negative 3.42. That's to 2 decimal places with the nearest hundred. So technically, remember, these are approximations. So I'm going to change this to my approximate symbol. Trying to get my decimal point to look like a decimal point here. Could be a little bit better. All right, let's go with that. All right, let's take a look at another problem. So again, with these right triangle problems, you always want to start by identifying your 3 sides. Again, label your hypotenuse first, which is across from the right angle. So the 9 is our hypotenuse this time. Then I would recommend you label the side opposite your angle. Our angle is this 17 degrees. So going across our triangle, that makes this bottom side the side opposite. And that makes our x squared then the side adjacent, which again is one of the sides of the angle, the 17-degree angle, and it's the side that is not the hypotenuse. So the sides that we care about are the sides that we have information about, which are the hypotenuse and the side adjacent. So we need to know, is that going to create a sine, cosine, or tangent ratio? So again, you can use SOHCAHTOA to help whenever necessary. So we have adjacent and hypotenuse. That's here, so that tells us it is cosine. So our equation is the cosine of 17 degrees equals our side adjacent of x squared over the hypotenuse of 9. All right, so this time we have to realize that we're still going to have to undo the division, but its purpose is to start isolating x, solving for x, because x squared is in the numerator, so we don't have to worry about getting it out of the denominator this time. It's already in a numerator, but we undo our division here, multiplying by 9 this time. And that gives us 9 times the cosine of 17 degrees. Here the 9's reduced to 1. 1 times x squared is x squared. Then we can take the square root of both sides. That's going to be us plus or minus the square root of this product here. And the square root of x squared is x. So now again, I would use my calculator. So again, I have parentheses around what I'm taking the square root of, and I have to have parentheses around my angle measure. All right, let's use our calculators. All right, so here we get x is about positive or negative 2.93. All right, let's take a look at our third example. So again, always want to start by labeling the sides of our triangle. So this time we'll start again by labeling the hypotenuse, which is across from our right angle. So that makes this side our hypotenuse. Then again, I would recommend you label what we call the side opposite our acute angle. And our acute angle this time is our 79 degrees. So going across our triangle, that makes the x squared plus 7 the side opposite. And that makes then our 8 our side adjacent, which notice is one of the sides of our angle and the side that is not the hypotenuse. So the sides again that we care about here are the sides that we have information about, which are the opposite and adjacent sides. So we need to know, is that going to create a sine, cosine, or tangent ratio? So SOHCAHTOA. So we have opposite and adjacent, which is right here. That tells us this is a tangent ratio. So we have tangent of our 79 degrees would equal our side opposite, which is our x squared plus 7, over our side adjacent, which is our 8. So now here is our quadratic equation. Again, quadratic because we have x to the second power, and we're going to solve this now for x. So again, we want to start by undoing our division, but this time it's not to get x out of the denominator, it's just to start solving for x. So we multiply both sides by 8. So we have 8 times the tangent of 79 degrees. Here our 8's reduced to 1. 1 times x squared plus 7 is x squared plus 7. Then we will undo our addition, subtracting the 7 from both sides. Now you have to realize, structurally speaking, this is a product, and that multiplication is done before the subtraction. So you have 8 times the tangent of 79 degrees followed by minus 7. Then we're going to undo our exponent, taking the square root of both sides. We get plus or minus the square root of this 8 times the tangent of 79 degrees minus 7 equals square root of x squared is x. So now we can use our calculator and round to the nearest hundredth, which is our second decimal place. Let's do that. So if you're not sure where to put parentheses, again, you need parentheses around the entire expression you're taking the square root of. And then for sine, cosine, and tangent, you need parentheses around your angle measure, like so. All right, so here we've got that x would be to the nearest hundredth about positive or negative 5.84. There we go. All right, next we're going to take a look at some practice problems. So pause your video here and give this one a try. Let's take a look at the result. So this one, hopefully you came up with a cosine ratio. Side adjacent and hypotenuse is what we have. And so you'd undo your division, multiply by 19, then undo addition, subtracting the 5, take the square root of both sides, parentheses around your 41 degrees, and around, of course, the entire radicand, and you have about positive or negative 3.06. Let's try another one. Pause here. All right, let's take a look at the result. This one, hopefully you came up with a tangent ratio. So this is your hypotenuse, which you know nothing about. And here's your 50 degrees, so this is your side opposite, and that would make your x squared the side adjacent. So tangent is opposite over adjacent. This time we have to multiply by x squared first, undoing the division. And this one is with the purpose of getting our x expression out of the denominator. So now it's over here on this side, and now we have to undo the multiplication between the x squared and the tangent of 50 degrees. So we divide by the tangent of 50 degrees on both sides, and then we can take the square root and parentheses, of course, around the whole thing and around the 50 degrees, which gives us a negative and positive 2.42 to the nearest hundredth. And that is the last practice problem. So that ends this particular lesson. You guys have a great day.